As I said, before I get started, I thought I would share a little bit about myself, and not to repeat everything that Stephen introduced me with, but why am I so interested in the mobility space? Just by background, I did grow up here in the UK, educated here in London at King's College, mechanical engineering graduate back in '82, and then went on to join Ford as a research engineer, actually at the Dunton Research and Engineering Centre. And over the 32 years that I spent with the company, I had the opportunity to live and work in the UK, in Germany, and the US, which is home for me now. And as was mentioned, my most recent responsibilities at Ford, and that really is over the past probably 8 to 10 years, was leading the global engineering team, and also most recently serving as the Chief Technical Officer. And in that role, along with obviously developing all of the vehicle technologies that go into our cars around the world, there was also a key area of focus on future mobility solutions. And it was that work that led to the development of Ford's Blueprint for Mobility. And that really was the genesis for this lecture, and I'll talk a little bit about that at the moment. Right now I'm working with a Detroit-based strategic investment firm called Fontanalis Partners, who are investing in early-stage mobility companies, serving as a board member of On Semiconductor, which is a fascinating industry for me, and I'll talk a little bit about multidisciplinary engineering towards the end. But for a mechanical engineer learning the semiconductor industry, I think you can appreciate it's very different, and I'd recommend any of you to try it at some stage. I've been a member of the IMechE all the way back to my student days. As Stephen mentioned, was elected to the class of fellow in 2009, which really was a tremendous honour for me. And thanks to my colleague Richard Folkeson in the audience for nominating me for that. Also a fellow of SAE International, and really a great believer in the continued professional development opportunities that the engineering societies around the world provide. And that really leads me to my current role at FISITA, and I guess in some ways helps connect the dots for this lecture. So what is FISITA? And we'll make a link in just a moment to mobility, but FISITA as an organisation was founded in Paris in 1948 during the time that the European automotive industry was starting to rebuild itself after the Second World War. It is the International Federation of Automotive Engineering Societies, with this mission of promoting knowledge sharing amongst the member community in a way that positively contributes to the development of safe, sustainable and affordable mobility solutions, and also helps guide the future direction of the automotive engineering profession. Through the global network of member societies, there are about 38 member societies around the world. FISITA does have reach to about 200,000 individual automotive engineers, and of course the Institution of Mechanical Engineers, the SAE, VDI, and many of the smaller societies around the world are part of the FISITA community. With its focus on mobility, STEM education, and promoting careers in automotive engineering, FISITA really plays a key role in helping to define the future of our exciting, challenging and rewarding industry. And as you can imagine, I'm extremely proud to be serving as president for the 2014 to 2016 term. Just a few examples of the type of activities that FISITA promotes are shown on this slide. Starting with the World Automotive Congress, which is a biannual event providing engineers from around the world the opportunity to share their knowledge, either through the presentation of technical papers or through attending subject matter sessions. This year we had our Congress in Maastricht in June. The next will be in Busan in Korea in September of 2016. Eurobreak is in its third year now and has proven to be a huge success amongst the brake engineering community. The World Automotive Summit is an annual event for industry leaders and decision makers, and actually our next year's summit will be holding here in London in November 2015. And then for the students and educators, we have a program which is called Your Future in Automotive, which provides travel bursaries and other student support schemes. So a number of my FISITA colleagues are here in the audience tonight. They're hiding in the shadows at the back. You're not going to get away without doing something tonight, so I'd encourage you afterwards to touch base with Josh, Tom or Manny and learn a little bit more about our activities at FISITA. So please, you guys could join me tonight. As I was preparing this address, I was also interested to learn more about Thomas Hawksley and his many accomplishments. And as the slide shows, he was actually a preeminent civil engineer in the 19th century, largely being recognised for his pioneering work in water supply infrastructure. Thomas Hawksley was the founding president of the Institution of Gas Engineers and Managers, and later served as president of both the Institution of Civil Engineers and, as we've heard, the Institution of Mechanical Engineers. He was also elected a Fellow of the Royal Society back in 1878. The lecture was dedicated in his memory by his son Charles Hawksley in 1913, and past topics have been far-reaching. And if you haven't already done so, I'd really recommend to you just to look back through the proceedings of the Institution of Mechanical Engineers to appreciate the rich history that has been since established in his name. This is the 102nd Thomas Hawksley Lecture. Last year's lecture, for example, was on developing 21st century spaceflight, and the year before, which was the 100th Thomas Hawksley Lecture, was on the exciting subject of Formula One racing, so as you can see, quite diverse in nature. Some of the major projects that he was credited with include the Rivington Pike system, which is shown here, the Papplewick pumping station, and the Trent Waterworks. And in his obituary, published in September of 1893, it was noted that Thomas Hawksley was one of the most eminent and best-known civil engineers of his day, completing numerous projects both here in the UK and elsewhere in Europe and around the world. The obituary goes on to recognise the many water and gas works that were designed and constructed under his supervision, and it also notes that he had the great merit of being the first to suggest and carry into practice the system of constant service in water supply, so the thing that we take most for granted today. This system provided one of the greatest benefits ever conferred on urban populations, as it combined the most free and ample supply of water with the almost perfect repression of waste and provided greatly improved sanitary conditions. So Thomas Hawksley clearly had a vision, and through that vision, he helped create a better world for future generations. So with that brief introduction and background, let me move on to the lecture itself. This is the outline for tonight. It's actually pretty straightforward, and my hope is that you'll come away with a better understanding of both the challenges and the opportunities that lie ahead, thinking about future solutions and how we can collectively contribute to helping make the world a better place. Maybe before I dive in here, a quick definition of mobility would be helpful. In the context of this presentation, I'm simply defining mobility as the safe, efficient and affordable transportation of people, goods and services wherever and whenever is necessary. I'd like to start out by taking you through my own thesis on this subject, and hopefully it'll help put the rest of the presentation into context. The basis for the lecture is that a number of macro societal and economic trends, which we'll dive into in the next few minutes, threaten the long-term viability of personal mobility as we know it today. Now, I recognise that might sound like a dramatic statement. It's easily made and is purposefully open-ended, but it does lead to my second point, that the existing automotive industry needs to innovate and reinvent itself or risk being disrupted by non-traditional players. At this time, just think about the parallels that we have in phones, cameras, and other industries that have been completely disrupted by new technologies over the past 10 to 15 years, and how huge economic wealth has been created by companies that barely existed even 20 years ago. At the heart of this revolution lies innovation, and the final point in my thesis here is that it's engineers who must lead the innovation needed to drive future mobility solutions, while at the same time continuing to provide high quality, safe, efficient and affordable vehicles for many years to come. We'll take a look at some of these trends along with the supporting data in just a few moments. But I should also say that the concept of mobility for all is not new. In the early part of the last century, civil engineers and automotive engineers were working together to build the foundational elements of the transportation system as we know it today. To help promote this, in 1925, Henry Ford captioned a newspaper advertisement with the tagline, "Opening the highways to all mankind." This started out by saying, back of all the activities at the Ford Motor Company is this universal idea, a wholehearted belief that riding on the people's highway should be within easy reach of all the people. It went on to say that the motor car, which is contributing in so large a measure towards making life easier, pleasanter and more worthwhile, has been made available to millions. Now that vision of being able to open the highways to all mankind, I would argue is as relevant today as it was almost 100 years ago. Although the interpretation of that vision will be quite different as we consider the future of personal mobility, the goal of providing access to safe, efficient and affordable transportation really is pretty much unchanged. Let's turn now to the so-called megatrends that are driving the changes that I'll be describing later. The megatrends that have the most impact on the future of mobility are shown on this slide, with the threats coming in the form of congestion, never-ending traffic jams around the world, and of course increased awareness and concerns around the economic and environmental impacts, particularly in urban areas. Let's take a look at each of these in turn, starting with population growth. There are around 7 billion people in the world today. This is projected to increase to 8 billion by 2024 and to 9 billion within our lifetimes. As you can see from the charts, almost all of that growth is in the underdeveloped nations and emerging economies. Now, although there may be no surprises for you in this data, it is interesting to look back at the 19th century to the time when Thomas Hawksley was pioneering infrastructure for a global population of less than 2 billion people, and to think that much of that foundational infrastructure is still in place today in a world of 7 billion people. Now, I know the geographical distribution of that population is quite different, and much of the technology has been reinvented, but I still find the numbers quite staggering. Equally staggering is the trend towards urbanisation, the number of people living in megacities, or urban areas with populations of 10 million or more people. In 1950, there were just 2 megacities in the world, Tokyo and New York. Today, there are 33, continuing to increase through to 2050, when 70% of the world's population is expected to live in an urban area, compared to just 20% at the beginning of the last century. From a mobility perspective, the challenges this presents should be obvious. Air quality issues, congestion, and parking, to mention just a few. Now, along with the increase in population and economic growth comes a dramatic increase in the number of vehicles in operation. Now, for you, those of you that are not in the automotive industry, this actually may come as a surprise, and that is the traditional automotive industry is still a growth industry and is expected to remain so for many years to come. Global industry volumes of around 80 million vehicles per year are forecast to increase to 100 plus million per year by 2016-2017, with much of this growth also being in the emerging markets around the world, particularly the continued growth in China, India, and to a lesser extent towards the end of that period, the Middle East and Africa. Compounding this annual growth takes us from about 1 billion vehicles in operation today to a conservative estimate of 2 billion, possibly as high as 4 billion by the middle of the century. 4 billion vehicles. Now, just to scale that for you, 2 billion vehicles, parked nose to tail around the world, and I'm thinking a kind of a Focus-sized car here, sort of 4 meters in length. 2 billion of those vehicles parked nose to tail would actually extend at least 8 million kilometers or 5 million miles, or 200 times around the world. So let's just say whether it's 2 billion or 4 billion, it's a lot of vehicles. And you can imagine the challenges that that presents. Now, the inevitable result of urbanisation and increased numbers of vehicles is, of course, more and more congestion, with huge costs to the economy. There have been many studies focused on quantifying the economic impact of congestion, and the numbers are all fairly consistent. As a couple of examples, costing the UK around £4.3 billion per year, £490 per car commuting household, and in the US, almost $50 billion per year, with an annual cost of $640 per driver. It's also been estimated that the average American spends more than 1 full work week per year stuck in traffic. This, of course, threatens the free movement of people, goods and services and forces the need for alternative solutions. A transportation model based on more and more personal vehicles is simply not sustainable, as we've experienced in cities like London over the past few decades. Now, the tagline on this slide is a quote from Ford Motor Company Executive Chairman Bill Ford, who a few years ago said, "A green traffic jam is still a traffic jam." And what he was indicating by that is that electrification, hybrids, battery electric vehicles alone are not the answer. They certainly help address the local air quality issues, but they do nothing to ease the issues of traffic flow or parking. So by now, I hope you're beginning to appreciate the impact that these trends are having and will continue to have on personal mobility. And this slide shows the future that we're trying to avoid. Global gridlock, never-ending traffic jams, with all of the previously discussed issues that they bring. The cartoon on the left also makes an important point. That is that alternative mobility solutions will require behavioural change. We all can't think that it's somebody else's problem. It also sets the scene for the innovation platform that I talked about earlier, imagining and creating personal mobility solutions that, from a user perspective, are more compelling and better experiences than sitting alone in a private vehicle, just as this cartoon says, wishing that everyone else was on the bus. So hopefully by now you've reached the same conclusion as me. And that conclusion is that the mobility model that we have today will not work tomorrow. If you haven't reached that conclusion, we may be looking at the data in a different way, and we'll have plenty of opportunity later to share different perspectives and questions. But for now, let's move forward with this in mind and start looking at some of the emerging solutions. This slide sets the scene. It's not intended for you to read it, but what it graphically shows is that almost every one of the traditional OEMs is working in this space, along with many non-traditional players, from large tech to startups. There is no single solution emerging. There continues to be vehicle-centric innovation, service-oriented models, and mixed-stroke multimodal transportation systems. Most in some way involve connectivity, a mobile platform, and real-time data, and most are focused on providing on-demand mobility. As I mentioned earlier, the traditional industry is at an inflection point. The opportunity is to innovate and reinvent. The threat is to be disrupted by others, who for tonight I'll continue to refer to as the non-traditional players. The mobility landscape is complex. Much of it is in what I would describe as experimentation mode, but I think the amount of activity supports the case for change and is also illustrative of the opportunity that lies ahead. Broadly speaking, these emerging solutions fall into 4 areas with much overlap and integration in between. We'll go through each of these in turn, starting with several alternative business models that are already proving to be commercially successful and globally scalable. Car sharing, ride sharing, and ride services have established themselves as popular alternatives to traditional taxi services and/or public transportation. The financial model is attractive for both the companies and the private individuals, and using smart algorithms, the experience can be personalised in a way that transport on demand can be called up in a matter of minutes from your phone. And I won't mention the name, but one of the companies, which is shown on this slide, that just appeared there, has just had a most amazing pre-IPO valuation of about 40 billion US dollars. So if you think about creating economic wealth in a short period of time, what an amazing example that we have there. I guess the jury's still out on how sustainable the business models are, also how the vehicle population will be affected. But all of that said, these services are maturing fast and appear to be here to stay. They're particularly relevant for city dwellers or commuters who may not own a personal vehicle or who may just prefer the convenience of a private car, but without the burden of parking, ownership, and all of the other things associated with a private vehicle. I'll discuss multimodal schemes like the Octopus system in a couple more slides in the review of integrated mobility systems. The overlap with this slide is that the business model is also changing, with seamless single-ticket payment systems and discounts to incentivise more people to go door to door, utilising the available modes of transport. Now, urban vehicle concepts, maybe more than anything else, convey the image of a modern, contemporary, city of the future environment. The key characteristics are shown on this slide. It's becoming an and product, with the small footprint being combined with many of the attributes that one would expect to find on a larger size vehicle. Manoeuvrability in traffic and ease of parking are the key why buys, along with the possibility of access to dedicated lanes in some cities. These type of vehicles may offer a partial solution in some scenarios, but they're unlikely to be the singular solution. In fact, the opposite may actually be true, with these potentially being second or third vehicles in a household, used only for city commuting, and in total, driving up the numbers of vehicles in service. Given the small size and need for affordable pricing, they're also likely to be low-margin products for the manufacturers, opening up the likelihood that they might be offered with other added value services. For example, preferred parking or other features that are designed to provide a superior user experience, something that could not be achieved with a traditional vehicle. Now, I mentioned integrated mobility systems earlier. These are interesting in that they also require a paradigm shift, in fact, a couple of paradigm shifts. Firstly, the service providers themselves need to focus on the city as the customer, as well as satisfying the end user. And secondly, the users themselves need to be open to change and willing to adopt a new mode of transport, potentially changing a daily routine that may be several years old. Advanced examples of integrated mobility systems may be found in Masdar City in the UAE, United Arab Emirates, which features semi-autonomous pods operating below the city streets. In Singapore, where overground, underground and waterborne means of transport have been stitched together to provide a seamless transportation system, and to a lesser extent here in London, where the Oyster payment system allows for easy use of trains and buses, although still lacking the A to B single journey planning found in some cities. What is clear is that no silver bullets have emerged, and the solutions being adopted are very much dependent on the existing infrastructure, from the clean sheet opportunity in Masdar City to the mature environment here in London. And moving on to enabling technologies, and there are many, the biggest of which are connectivity and the various types of sensors and processors that have resulted in a convergence between the consumer electronics world and the vehicle. In addition, huge amounts of data, whether from the vehicle, customer device or infrastructure, combined with incredibly powerful analytics, enables a seamless and personalised user experience. Now, I'd like to quote from a recent example in Forbes magazine, which was authored by the tech writer Arjun Shuter. And what he said is, it seems that no industry is safe from the buzziest of buzzwords, the Internet of Things. From the titans like Google and Apple launching platforms to bring Android and iOS into the car, to OEMs like Tesla pushing the boundaries of in-car computing, his words not mine, to the laughable yet inevitable rise of self-driving cars, cars are becoming equal parts hardware and software. He goes on to say the resulting wave of connectivity will profoundly impact the auto sales and finance industry. 50% of all new car sales projected to be sold online by 2015, 100% by 2025. Connectivity will fundamentally shape how consumers purchase vehicles, how they pay for finance and insurance, and even whether they choose to buy a vehicle at all. Now, some of the numbers may be debatable, but the reality is that the vehicle will soon be just another device on the Internet of Things, another node on the network. Now, so-called intelligent transportation systems, where vehicles communicate with each other and or the surrounding infrastructure through cellular-based or DSRC, dedicated short-range Wi-Fi communication, do offer potential benefits in safety and efficiency. A number of pilots have been and continue to be conducted around the world, demonstrating benefits in collision avoidance and traffic management. Progress has been made in standardising the messaging protocols for the basic safety messages, essentially ensuring that all vehicles speak the same language, but challenges do remain around standardisation of hardware and harmonisation of regulations. Statistically, it's been estimated that a penetration rate of 40% would start to realise measurable benefits in traffic flow management, but around 80% would be required to achieve significant safety benefits. Now, you can imagine with the current vehicle refresh rate, this level of penetration will take many decades to achieve, opening the door for an aftermarket solution to help accelerate the adoption rate. Challenges remain around security, privacy and liability, in addition to the question of who pays for the vehicle hardware and infrastructure. Despite these issues, there is clearly much opportunity in this area. The motivation in the US alone, where there are still over 30,000 traffic-related fatalities every year, many of which could be avoided in a network of intelligent vehicles, really is compelling. So either through voluntary adoption and or regulation, I'm confident that connected vehicles will increase significantly in volume over the next few years. Now, in my opinion, driver assistance and active safety features really only belong on the periphery of the discussion around future mobility solutions. The reason, though, that I've included them here is because many of the features that are becoming commonplace on today's vehicles do actually provide the building blocks, the foundational technology and knowledge for the self-driving vehicles that I'll discuss on the next slide. Along with many others in the industry, I believe there'll be a continuing evolution of these systems, offering more and more advanced functionality, ultimately resulting in autonomous driving features. Now, think about some of the features that are highlighted on this slide, whether it's adaptive cruise control, lane keep assist, automatic parking, automatic emergency braking. The sensors, the actuators, and the algorithms are already in place to control the speed and direction of the vehicle. In layman's terms, the accelerators, steering, and brakes. The step towards full autonomy includes high fidelity sensors, more processing capability, and of course much more sophisticated algorithms. Advances continue to be made across the industry, and combining these vehicle-centric technologies with the connected vehicle technology that I described on the previous slide is also synergistic, and in many people's minds may offer the ultimate solution. much like the air traffic control system that monitors aircraft even when they're flying on autopilot. Now, if only I had a penny for every time that I've been asked about autonomous vehicles, and I always answer it the same way every time, and that is I really don't know. And the reason for my answer is that it very much depends on your definition of an autonomous vehicle. NHTSA, the US Highway Transportation and Safety Agency, have published a set of definitions which do help. Certainly at level 0, which describes a vehicle with no automated capability, and at level 4, which describes a fully autonomous vehicle, where the machine is in charge and there may be no requirement for a licensed operator to be in the vehicle, with all the occupants being passengers. Now the problem is in between, where you find these levels 1, 2 and 3 that describe progressively increasing levels of autonomy, but always requiring a relationship between the vehicle and a licensed operator, aka the driver. As you can imagine, this introduces a degree of complexity beyond just delivering robust automated driving functionality, as it now requires an equally robust hand-over, hand-off process or procedure between the driver and the vehicle, or vice versa. This is particularly difficult in conditions of uncertainty, where the handoff may need to take place in a very short period of time. This may also be the reason that the industry continues to use the term driver assistance to indicate that a driver is in control, and active safety indicating that a vehicle intervention can be expected, for example, automated emergency braking. Autonomous remains as an aspirational vision, but one that is getting closer every day. So I really don't know. What I do know, though, is that there are some really smart people working on developing fully autonomous vehicles. The current capability is very high, but the challenges and the issues that remain are complex and will likely take many years to solve. The motivation to develop cars that don't crash, give time back to the driver, and significantly increase the utilisation of the vehicles on the road is compelling. But how long it will take to deliver robust functionality and how affordable these vehicles remains to be seen. One thing for sure, though, it really is an exciting time to be an engineer. Now, along with the technical challenges, there are a number of other considerations which apply equally to both the world of connected and autonomous vehicles. Matters regarding the legislation, security, privacy and liability of these vehicles remains top of the agenda, requiring close cooperation between industry and lawmakers. Other issues include who pays for the infrastructure, customer acceptance of these new technologies, and some ethical questions around decisions that an automated vehicle might make in particular circumstances. I don't plan to dwell on these issues, but I think you might imagine the angst that exists in some areas and the behind-the-scenes work that is being done to develop an acceptable framework to allow for the safe and secure operation of these vehicles. Now, one other plug that I make is always the need for harmonisation of regulations. Diverging requirements is hugely inefficient for the industry, with pass-through costs to the customer, which offer little or no value to the end user and often just result in delaying the introduction of new technology to market. So having reviewed the macro societal and economic trends that challenge the mobility model as we know it today and looked at some of the emerging solutions in enabling technologies, I hope you would agree with me that the mobility model that we have today is evolving. And whether progress is fast enough is debatable, whether enough innovation is coming from within the traditional industry is debatable, and whether a disruptor from outside the industry will ultimately win through are all areas for an interesting discussion. But what is clear and what is exciting is that this change is happening and at a seemingly accelerating pace. The other thing that I find exciting is that as this technological change is taking place, the automotive industry continues to grow as I mentioned earlier, from that 80 million kind of number today to 100 plus million by the end of the decade. So there really is a need for engineers of all disciplines in the automotive industry. There are many exciting career opportunities, and we can all be ambassadors for careers in automotive engineering. Or maybe even for the next generation, we should refer to it as mobility or something similar to indicate that change that is taking place. And that leads me to the final point in my thesis, and that is that engineers must lead the innovation that's needed to drive these future mobility solutions. And I put this slide together just to share some thoughts that I have on that role for the next generation of engineers and to capture what it is that I look for in an innovative mind. Now, first off, I always say that technology is the enabler, it's not the solution. And I think the points on this slide capture my views on this quite clearly. The first is think big. Think ideas that can really change the world. And then imagine the user experience. And then cascade that experience down to a set of engineering requirements where you can then leverage technology and use that technology to deliver that experience in the highest quality, most accessible way. I'm also looking for people that believe that engineering innovation continues to contribute to making the world a better place, and people that can really dream the impossible. Now, I know these points are no substitute for formal education, training and experience, but I do believe they may offer a different and potentially more exciting vision for our young engineers than some of the more traditional descriptors that we tend to use. And on this slide, I'll just share a few of my thoughts around what this is going to take. Again, starting with this vision of being able to change the world and having and carrying an ambition of creating a better world. And I've mentioned before the need for a multidisciplinary approach. Being able to work effectively in multidisciplinary teams will be absolutely essential to creating the mobility networks and solutions that I've been discussing this evening. In addition to the traditional disciplines of mechanical, electrical and electronics, civil engineering, let's not forget the dependency that we have on computer science, software and analytics, and the experiences and value that these engineers create for the end user. We should all continue to support and be advocates for STEM education programs, focusing on providing the foundational knowledge, but maybe also quickly moving to teach a more multidisciplinary approach to application engineering, as I've been describing throughout. And of course, let's all be ambassadors to support and promote careers in engineering in the broadest sense. So now, bringing it all together and leading us to the discussion session, let me summarise as follows. And the summary is that these macro societal and economic trends, particularly population growth, increasing numbers of vehicles and urbanisation, threaten the future of personal mobility as we know it today. The mobility model we enjoy today is not sustainable in the sense that ever-increasing issues of congestion and, I might add, changing consumer expectations will not work tomorrow, and it continues to evolve. Emerging solutions are largely in the experimentation phase, although rapidly accelerating in some areas. And finally, engineering innovation will help drive the future of personal mobility. It really is an exciting time to be an engineer, and we all have a role to play to ensure that that next generation of engineers are equipped to lead us into a world that is likely very different than we've experienced over our lifetimes. So I'd like to pose to you the question, what do you think? We've got plenty of time for questions, but I'd also like to promote this as a little bit of a discussion between us to get your thoughts and vision for the next 10, 20, 30 years. And within the view that I've presented tonight, there really are no right or wrong answers. If we had the perfect crystal ball, we probably wouldn't be here today. So thank you all for your attention. I hope I've got you thinking here. And maybe somebody would like to open up the question session. Thank you.